Okay, next. So I have explained about this transmitter and receiver concept. So if you are being asked to draw, apa dia lambat ni? Tak ada. Oh, dia lambat. Delay. Okay, if you are asked to draw the transmitter and receiver system, yeah, maybe the question. So just use all these four components. So if you look at the receiver consideration in this slide, for example, the minimum SNR, for example, telephone line is 30 dB. This is minimum. TV system 40 dB, good music 60 dB. So if it's less than 30 dB, so you cannot speak within each other in the telephone. So this example of why you are using the SNR. So beside the SNR, there are lot more of receiver system considerations. So you have the receiver sensitivity, selectivity, response rejection, intermodulation rejection, frequency stability, radiation emission. So there are a lot more. So you can read it by yourself. You can further Google, or you can read from the book in order to know the other system consideration. So lambat saya punya slide ni appear. Okay, so you have learned about what we call the super heterodyne receiver in the principle of communication. So basically, this is for the FM. Okay, so for radio, so normally you have the 88 until 108 megahertz. You have about 20 megahertz of bandwidth. So reception of the receiver at the antenna of your radio. So then it amplify, goes to mixer. Then you have a filter and another amplifier, and so on. So this basic of super heterodyne receiver. So what I want to, so maybe later, or I want to explain about the image frequency. Boleh kot. Mana nak masuk? Okay, I want explain about the image frequency. Mana saya punya? I'm searching for my notes. What is image? So image means the identical frequency that appears in the receiver, which is maybe not used maybe not useful, but it is can interrupt the original signal. At the receiver, okay, at the receiver you have the antenna here, you have the receiver or oscillator, and so you have the RF signal, you have the local oscillator, and in the end you want the IF. At the receiver. Okay. So normally, when you want to solve this frequency problem, so you have the main intermediate frequency, FRF minus FLO. So this is how you want to calculate the intermediate frequency. The radio frequency minus the local oscillator frequency. So is this the basic formula in order to get the intermediate frequency. So in the same time, image also occur. Where the FIF equivalent to F image minus FLO. So this is why the second image it appeared. So if we bring the title back, F image, SCI image equivalent to FIF plus FLO. Okay. So this where the image occur. So from the formula above, okay, from the formula above, so we have two formula. Main formula, okay. Nak tukar color, We make the FRF as the title. So we have FRF is equal FIF plus FLO. So this is the first 2A. And again, image is appearing. At another side, pening. Tak apa, ikut je yang. Just follow the blue one. Okay. So then, so this is the equation number 1. This 2A and this is equation 2B. Okay. Then we have the 2A in 1. So you take 2A into equation number 1, you will get, okay, this FRF equivalent to FIF plus FLO goes into the equation number 1, then you will have a FIF equivalent to plus FIF. So this is 2 in 1, 2A in 1. So you have the positive intermediate frequency. And then see the equation 2B, you put in 1. So you put the second one, FLO minus FIF inside the equation number 1. And you will have the FIF equivalent to minus FIF. So where did this come from? So in the frequency response, okay, when you have the receiver after the mixing process or at the receiver, okay, so normally this is what you want. This is the signal that you want. But sometimes, most of the time, the image will appear additionally here. So this is the frequency image. Most of the application don't want this. This part is we don't want. So it's been removed using the filter or so on. Okay, so this section just to show you how the image frequency occur. So when we go to the subject or the components called the mixer, so we will again explain about this problem, because when you go to the mixing, the image frequency will be very near to the original signal that you want. So it will have a problem, especially in order to remove the image. So basically, so today, you just need to know that this equation, the blue one, in order to prove that the image frequency exists. Okay, so the next other is about the signal to noise ratio. So wanted signal power level to unwanted noise power level. So this is what we call the SNR that I have explained before. Saya rasa saya punya suara tak sampai ke? Slightly lain So I think the delay with the sound. Never mind, I will just continue. So I can see the laptop and the tablet that I use is not in the same synchronized. Okay, beside that, you have the noise figure. Okay, noise factor. You also have learned that. But in this course, I won't touch much about this noise figure. I will touch only the signal to noise ratio. I won't touch about the cascaded network. Equivalent noise also I don't touch. So next class, so it's almost one right now. So I will explain about the dynamic range. So the dynamic range is important, especially in designing the mixer amplifier, where to show that the area where the components function properly. Some parts is not linear, so it cannot operate properly. For example, amplifier. Some maybe mixer is important in order to use in the nonlinear region. So our next class maybe on Sunday. So we will touch about this dynamic range. So why I explain to you today, because of maybe the first test or final exam will touch about this section. Secondly, don't think much about the test of final exam. Basically, this the knowledge, the knowledge for the starting or for the communication system. So you need to know about the transmitter and receiver properly before we go to the designing specifically for the circuits. All right, so that's all for my explanation. So maybe right now, mana ni? I open for question if you have a question. So ada soalan? So today class just for introduction. So I can see now the attendance list. So I will extract it from here. You can see. So next time login your using your email address is better. Mana ni? Okay, I can save the class list. So what happened here? Okay, for example, just to show you why I don't use the QR code. Ada email tak? Tak ada. Okay. So if you use this, so this today, time date, till time, last seen. So masuk 11.53, keluar 12.54. Okay, sekarang lah 12.54. Minutes of checks 57 minutes. Okay, so for those who just 2 minutes, 9 minutes, so ada 1 minute. Oh tadi Henry Kobe. Okay, so I know who is in my class or not. Siapa ponteng, saya tahu lah. Okay, so jangan ponteng kelas.
Okay, sir. Okay, sir.
Alright. So for those who are not yet in the class, you can contact siapa ni? So our class representative is siapa Witness ke? Sarwin ke? Saya lupa lah.
Sarwin.
Sarwin Okay, Sarwin is our class representative. So we have created a WhatsApp group. Also, you can add me. Okay, mana chat? Saya nak cari chat kat mana? You can ni apa Sarwin share your phone number for your friend to contact so that you can add in the WhatsApp group.
Okay, sir.
Mana chat ni? Oh, sini. Tengok tu pening nak cari. But sir, in the class without quitting, never mind. I think I didn't saw my name Lim Zizian. Tak tahu. Kenapa tak ada your name? Kenapa tak ada? Kenapa dia tak record? Apalah, nanti saya record lah. Ini easier Okay. So anything else?
Oh, doktor.
Saya pun tak pasti This is my first time using this. Okay, so Sarwin will share his phone number that you can contact him maybe to add up in the group, WhatsApp group. So if no question, we end our class now and see you maybe on Sunday. All right. Okay, thank you everybody.
Thank you, sir. Thank you, sir.